Alrighty, everybody. Hello, hello, hello. Graphing transformations, eh? I'm feeling a little saucy here right now, and let's do a trig graph, right? Get things rolling, here for today. Graphing negative sine of x. Now, remember here the directions. Say to graph each function without using a calculator. Now, obviously with the way this is going, you can use a calculator with the hybrid instruction this year, but in terms of teaching it, I'll do it, without the calculator. Draw all necessary points and asymptotes. So, listen, when it says draw all necessary points, it depends on the function. It's like, well, how many points do you want? Depends on the function. The cubic function had 5 points I want to see plotted. The reciprocal function there had 2 points, actual points, and then draw the curve. So it depends on the function. The ln graph, I just wanted to see that 1, 0, and then, draw the curve. Sine of x. Sine of x, and we'll do this, all right? We'll do sine of x in the interval from 0 to 2 pi radians. Okay. I'm not going to go negative 2 pi to 2 pi. So sine of x, your regular sine graph, was from 0 to 2 pi is the first half was a mountain, and then the second half was a valley. Sine graph has a high of 1 and a low of negative 1. Remember, because this is just the unit circle unraveled. The unit circle has a radius of 1, right? So it's not, you're not going to have a y value go past 1. All right. And have it be less than negative 1. Okay. So that's the range, right? The range of the sine graph is from negative 1 to 1, right? Because, remember, this is the unit circle. And at 90 degrees, or pi over 2 radians, right, that point right there, where this terminal ray, they call it, intersects the unit circle is 0, 1. Down here at 270 degrees, or 3 pi over 2 radians, right, that point is 0, negative 1. Right, there's no point below that, right? And that's what this is right here, this point. Right, that's negative 1 there at 3 pi over 2 radians. Right, so this is the top half of the unit circle right here, and this is the bottom half of the unit circle. This is from 0 to pi radians. So this is pi right here. And in between 0 and pi is 90 degrees, or pi over 2 radians. And then the second half is from pi to 2 pi radians. Pi radians, remember, is 180 degrees. 2 pi radians is 360 degrees. All right. In between is the 270, which is 3 pi over 2 radians. Okay. So yeah, that's what we got. All right, that's what we got here. So this bottom half of the unit circle is the valley here of sine of x. top half of the unit circle is the mountain here from 0 to pi radians. Okay. You know, graphed according to the y values here. You know, so all of these y values on this unit circle at that specific angle. All right, remember, these are all angles here. This is, you know, like your 30-degree angle, right? If you really got in depth with the unit circle last year, I don't know how much you did, you know, with it. All right, so at 30 degrees or pi over 6 radians, right, what's the y value? You know, and that's what's, you know, like at pi over 6, if this is 90, so like pi over 6 would be right here. So whatever, you know, whatever this y value is, it's going to match that y value there. So the graph of y equals sine of x here, the graph, not the unit circle, the graph right here, all of these y values are the y values on the unit circle at that specific angle. Right, you draw angles here from the origin. Right, that's your vertex. So all of these angles from 0 to 360 degrees are represented here on the x-axis of the graph of sine of x from 0 to 2 pi. And they're all the y values. That's all. That's what the graph of sine of x is. So, anyway. So, 0 to 2 pi radians. Let's see here. Pi radians, remember, is approximately 3.14 radians. So, how am I going to do this? 2 pi radians is 6.28 approximately. So, 3.14. Let me start scaling this out now. That's my pi radians. 3, 4, 5, 6.28 is my 2 pi radians. Pi over 2 is approximately 1.5 radians, right? It's 3.14 cut in half, right? Pi over 2. And then 270 degrees is between the pi and the 2 pi radians. So it's 3 pi over 2. 3 times 3.14 is 9.4, right? You know, approximately divided by 2, right? 9.4 divided by 2, like 4.7, right? Approximately. Right, so 3, 4, so 4.7, like right there. Is 3 pi over 2. So since I'm only graphing the negative sine of x, you know, I can adjust the y-axis here so this graph is not too small. So I have a little bit of space here. So I'm going to do 4 lines for 1 unit. Just to give myself some space. You don't have to do this, but since it's the only graph on here, you know, might as well. So remember, we're not graphing sine of x. I mean, you can graph sine of x here and then like take it away if you want. You know, if you want to graph the original on here, but, you know, go right ahead, right? Just the points if you want, right? Remember, sine, regular sine starts at 0, 0. Then it gets to a high at 1 at pi over 2 radians. And then it comes down to the x-axis here at pi radians. 3 pi over 2, it bottoms out. Right, negative 1. And then at 2 pi radians, it's 0. Right, so, you know, if you want to sketch this, it's fine. So that's sine of x. That's regular sine of x right here. All right, so this is not, the final answer. They want you to graph negative sine of x. Right? Negative sine of x. So how are we going to do that? Negative sine of x. Well, it's a reflection, right? You see a negative here, right? It's a reflection, right? Once you see a negative, and it's either a reflection in the x or the y-axis. Are you negating just the x, or are you negating the whole function here? By having the negative on the outside, you are negating, right, on the outside here, not by the x. You are negating the whole function. All right? The entire function is getting negated here, so that's going to be negative y, right? F of x is y, so you're negating the y. And if you remember the coordinate rule here, that's a reflection in the x-axis. So y equals sine of x, we are reflecting that over the x-axis. So take these 5 points here that I just plotted, right, with sine of x, and reflect them over the x-axis. Right, 0, 0 is going to stay at 0, 0. Here at the pi over 2, right, it's going to jump down to negative 1. Right, just bounce them off of the x. Pi, there, the value at pi radians is going to remain there. Here at 3 pi over 2, it's going to jump up to 1, and then at 2 pi radians, it's going to stay. Right? And then we'll get rid of this, right, so we can not get confused here. And connect the dots, right? So you're going to get a valley first and then a mountain. So that is the graph of y equals negative sine of x. All right, what did I do there? All right, so this is y equals negative sine of x from 0 to 2 pi radians, right? Okay, it didn't specify here, right? The interval, so I'll just do the standard, which is 0 to 2 pi. All right, so that's good. It's been a little bit of time there. That's fine, but I wanted to talk about the unit circle, the connection, right? The connection there. All right, let me do part H. All right, let me do part H here, and then we'll see where we're at. So this is ln. All right, ln graph. ln of negative x, right? Look at that. Here, the x, it's just the x, not the entire function, is getting negated. Right? It's just the x. So what's the coordinate rule, right? When it's the x getting negated, that's a reflection in the y-axis. Right? That's what's going on here. The ln graph is getting reflected over the y-axis. And also, remember, the ln graph is one of the 3 basic functions that has asymptotes. Right, so your ln function, right? So I'm graphing the regular guy now. ln of x. Remember, is the inverse of e to the x. It contains the point 1, 0, ln, right? ln has 1, 0. And if you remember, e to the x has a horizontal asymptote at the x-axis, which means ln is going to have a vertical asymptote at the y-axis. You switch the x and the y, right? And then, you draw your curve here. Right, your ln graph. And there it is. So this is y equals ln of x. Natural logarithmic function. So we're going to reflect that over the y-axis, people. Reflect it over the y. So take the point 1, 0 and reflect it over the y-axis. Right? 1, 0 reflected over the y-axis is going to go to negative 1, 0. What about the vertical asymptote? The vertical asymptote of the original y equals ln of x is on the y-axis, right? So you reflect that over the y-axis, right? It's not going anywhere because it's already on the y-axis. So that's going to remain, right? The vertical asymptote of ln of negative x, right, will remain the y-axis. And then, just visualize the curve there, right? Visualize ln getting reflected over the y-axis here, right? You can see it, right? It looks something like that. So just like I said, the only point I need to see there plotted is the reflection of 1, 0 over the y-axis. And just draw your curve now. Let me do it in blue here, right? So it matches. And there you go. You don't need to label it, but I'll do it here. Like, ln of negative x. You don't have to label. It's the only graph, so there you go, people, right? That's your ln, all right? That's your ln graph. Now, oh yeah, I forgot I didn't get into the x cubed. I said I would. Maybe I'll do that in the next video, right? If I don't forget this time, right? Part G. I said I was going to talk about that here in this video, but I didn't. How it's the same, right? How it's the same there. All right, I'll do that next. I'll do that next here. I won't do it now. I'll lead off with that in the next one. Hopefully I won't forget, right? You know what? Let me zoom in on this. All right.